Alright guys, welcome to Math 0314, Section 6.2, Rational Exponents. And if you watch 6.1, this is essentially an extension of 6.1. So last time we said that writing something raised to the 1/3 is equivalent to saying the cubed root, right? So either way, they mean the same thing, and the cubed root of -8 is asking what number times itself 3 times gives me -8. Now, we also, if you recall from last time, said that if it's odd, it's okay that the number inside, which is called the radicand, or the argument, can be negative, right? And for clarification, this is what's called the index. So when the index, whatever the index is, if it's odd, then it's okay for the radicand or the argument to be negative. So the answer here, if you haven't come to the conclusion already, is -2, because -2 times -2 times -2 is -8. So in number 2, we have what number, well, this means the same thing as the 4th root of 81, but the question is asking what number times itself 4 times gives me 81, and that number is 3. Moving on. Number 3, now this is a very interesting case. What you have to realize is that because this is not in parentheses, the 1/2 power is only affecting the 100. So remember, in PEMDAS we have to play with exponents before we multiply. So that -1, that negative sign in front is really -1. So this problem is really saying this. So we know that that is the same thing as saying this. Remember, the square root, implied in the square root, is that the index is 2. But this is, the square root of 100 is 10, and we'll tack on the negative sign. Now, number 4, because it is in the parentheses, means the square root of -100, which for now we're saying we do not know. Then in number 5, so this, what you can see is that this is really just a review of exponent rules and 6.1. So a negative, if you don't remember, negative means reciprocal, which is just a fancy way of saying that you move the number to the bottom or you put it in the denominator. So this is 1 over the square root of 16, which is 1 over 4. In number 6, this is where we get to something that's even more interesting. What I want you to recall or realize is that 2/3 can be written as 8 squared to the 1/3 power, or, if you prefer, 8 to the 1/3 squared. And the way we could prove this is that we know that when we raise to another power, we multiply. So if you multiply, whether you multiply this version or this version of the exponents, you would get back to this. With that being said, now we can tackle either version. This one, if we clean the inside first, we'll get 64 to the 1/3 power, which would give me 4, because 4 times 4 is 16, and 16 times 4 is 64. This version would give me 2, and then if I square that, I would get 4. So realize that whichever version you take, you actually will get the same answer. Now, the thoughtful question is, which version is actually better? Well, the question is, what do you mean by better? But I mean, which one is going to be more efficient? And you can see that this version right here is going to be more efficient because the numbers are smaller. So my advice is, if you can, play with the fraction exponent first, or the proper fraction exponent first, and then play with the numerator, or play with the denominator first and then the numerator. But either way works. And another way of thinking about this is that because we're multiplying, we're using the commutative property, which allows me to, which is just saying that 2 times 3 is the same thing as 3 times 2, or A times B is the same thing as B times A. So we can switch the order, and when we switch the order, we go between these two. Okay, beat that up a little bit. Go ahead, if you haven't done so already, pause the video and try numbers 9 and 10. Okay, I'm going to assume now that you guys have taking a shot at numbers 9 and 10. Let's see what we got. So first off, it's negative, so we know that it goes to the denominator. We have, from the previous example, we know that we want to play with the fraction first. So what is 4 to the 1/2? Well, it's the same thing as the square root of 4. So this is 1 over 2 cubed. 2 cubed is 2 times 2 times 2, which is 8, and there's my answer. On number 10, we have a negative 81. Again, I said play with the fraction first, so we're going to play with 1/4, play the denominator first, I suppose I should say, and then we'll cube it. So we know that the fourth root of negative 81 is negative 3, and this is raised to the third, which is going to be negative 27. Okay, so be careful, because a lot of times when people see negative 3 to the third, they want to say negative 9. Negative 3 to the third is negative 3 times negative 3 times negative 3. Or is it? So here's an interesting question. Can I take the fourth root of negative 81? And the answer is no. So this actually has no solution. So you have to be careful, right? Because the fourth root of negative 81 is not negative 3, right? If I did negative 3 times negative 3 times negative 3 times negative 3, we'd be getting 81, not negative 81. So there's actually, this is incorrect. The answer is no solution. Got to be careful. All right, so if you haven't done so already, let's talk about this together. So in this section, we're going to convert each expression to radical notation. So what we've been saying is if we have something, let me use x here, to the a over b, this is equivalent to saying x to the a, taking the square root with an index of b, if that makes sense. Or you can say x to the a over b is the same thing. This is really what we've been doing. And on the outside you have a. Either way, it's the same thing. So the book is going to use the first one. So this is the same thing as 3 with a as the exponent and the index is 5. Okay. The silly way to remember this is to think of a person on a horse. So at the end of the day, the horse goes outside and the person goes inside. Okay. So let's look at this one here. What can we do here? Well, because these both share a 1/3, can we just say 5x cubed root? That would be okay insofar as the 2 is here. What you cannot do in this situation is say this. This would be inaccurate. So you have to, because you're implying that you're squaring the 5 as well. So this would be wrong. This is the correct answer. And this is what the book is asking you to do. 13, you have to remember your exponent rules. So because the 3y is not in parentheses, this is just the fourth root of y with a 3 in front. Same thing with 14. So we have the 9. It's negative, so we have the z. And then the million-dollar question is, what's the index? Well, hopefully it's clear that's going to be the denominator, which is 4, and 3 is going to go with the exponent of z. Now, it's asking you to do the same thing, but in reverse. So what we said is if you're in the inside, you're riding the horse. The key with this one is that you have to remember that 7a has to be in parentheses. If you just write 7a, remember we said because the index is 2, this is 1/2. If you wrote this, this would be incorrect, right? This is a quantity because they're both being affected by it. If you technically wanted to write this, this would be correct as well, but this is what everyone's fishing for. This is, in fact, ironically, is this, right? So here we have, I'll rewrite it, but because only a is being taken as the square root, this is going to be our answer. So the last three are a combination of the exponent rules and what we've discussed. So, and they're asking you to simplify. So we're not converting, we're just simplifying this. So go ahead, if you haven't done so already, pause the video, try this one, and this one on your own, and compare it with what we get together. So assuming that you've given these problems a shot, let's do them together. So we know that when we multiply two numbers with the same base, we can add the exponent. So this is y to the 2/5 plus 3/5. They're essentially trying to intimidate you with fractions. But we know if the denominators of our fractions are the same, then we add the numerators. So we get 5/5, which is just y to the 1, or simply y. And number 19, when we divide, we're subtracting. So this is actually 6a to the negative 1/2 minus 3/2, which gives me 6a to the negative 4/2. Again, similar to the last problem, the denominators are the same. So we just add the numerators, or we do -1 plus -3, or -1 minus 3. This becomes 6a to the negative 2. Now be careful here. Only a is being raised to the negative 2, so this is also 6a squared. Another approach to this problem, there are many ways you can approach math problems, and that's kind of the cool thing about this, about math. Some of you may have done this, some of you may have just dropped a to the 1/2 to the bottom so that they would match, so the denominators would be together. And then in this case, we would, because now we're multiplying, we would end up adding, and we would add and get a to the 4/2, which then would just become 2, so we'd be right back here. So, and if you figured out a different way, as long as you get 6/a squared, you're in good shape. All right, 20 is the big one. When I look at 20, I want to see if I can clean up the inside first. In this situation, I cannot. So I'm going to distribute the 4. Right, we said when we raise to another power, we multiply. So this is s to the 4/2 times t to the 4/3 all over w to the 12/4. Okay, so you can see that this is cooked up. So this becomes 2, this becomes 3. So we're left with s squared times t to the 4/3 all over w cubed. And that's it. And that is it. That's the end of the section. So hopefully this wasn't too bad. The key is to realize as we work through these that these later sections are just adding one little sprinkle into the foundation of what we've done this entire semester. So let's make sure that we're keeping up to date with everything. Keep working at it. And I'll see you guys in the next video.